ଷ୍ଟାର୍ଟ ହେଇଗଲା। ଆପଣଙ୍କୁ ଲଗେଇ ଦଉଛି। ଆପଣଙ୍କ କାଉଣ୍ଟ ଡାଉନ୍ ଚାଲିଛି 58 57
ଏଇଭଳିଆ
ହଁ
ଉତ୍କଳ ଅପେକ୍ଷା କରିକି ବଇଛି।
ହ୍ୟାଲୋ
ବ୍ୟାନରଟା ବି ପଳେଇ ଆସୁଛି ନାଇଁ। ପ୍ରଥମେ ଟିକେ ଦେଇଦେବେ। ହଁ ଲୋକ ଯୋଡ଼ି ହେଲେଣି।
1
ସେ ଉତ୍କଳ let us start. Good evening friends. As per our commitment, we are starting the live session. As planned yesterday, we wanted to communicate the concept of armature design and how are they made from educational purposes to commercial. All descriptions will be discussed. To start with, Viewers, kindly take a note. This is the magnet, both the poles, one pole, another pole. It is a compact and powerful magnet. So if you are having a magnet like this, then magnet part is over. See the gap I have maintained from the surface of the pole to the armature. Even though this gap prevails, you will observe how I test initial round, and then we will discuss in detail. When I test, I rotate this side for camera to catch properly. See, first testing should be like this. Your series lamp should be on. This confirms that your current is ready. And then armature, as you know, commutator is important part. So what we check here, the moment we touch red and black wire, one up, one down, over the commutator section, it is pleasing and amazing that none of our previous armatures function like this. If you have observed the previous uploading videos, see those armatures did not function like this. We will upload again this particular video in another episode, but this is excellent in my opinion. And now I go to depth, how we design the fundamental armature. I remove it. See, the idea is like this. I have used two pipes only, making a hole on the board so that I can dismantle any moment and load another armature like this. Let's look at this armature, and this armature is the fundamental armature. How I have made, I describe a pipe, PVC pipe like this, both the ends glued by some other material, same material, sunboard, and a forma here to house the coil. See, the fundamental armature says it has got a single coil having two sides, one this side and one side towards me. If I reverse, my side will go to you and your side will come to me, like this only, one side, the second side. It is very simple. If you take suppose 50 meters of wire, 32 gauge enamel copper wire, you do have two ends. You start continuing like that on this format, and then at the end you have two ends, and those two ends need to be soldered onto the half ring, that means the half segment, the commutator. See how I show you the segment, that is more important. This is not a total ring. Suppose this is a cylindrical arrangement. We have cut it, half cut here. You can see by your camera, and another half cut is here. That means half of the ring upper side and half of the ring bottom side, and one wire is soldered here and the other end is soldered here. So this is complete, and your shaft is ready. Before that shaft, what material? Just an iron nail, cut both the ends, and this is ready. Insert through, have a glue. So depending upon your length of the shaft, you have to arrange your arrangement like this. Now what I am to do, I have to post my armature on the frame. If this is ready-made. Before you test, please remember every sort of arrangement can be done here itself. Height, alignment, linearity, you can check first. If it is free here, then you may start. Let's start here. So where to connect? The same process. First test whether your test lamp is ready. That means power is active. It has got two terminals. Remember I said this is a continuous piece of wire. So if you want to test that, whether your wire is intact or not, first what you have to do, make the armature like this. Vertically conductor should be maintained, and two ends you connect your terminals, and you see your lamp is glowing. That means it is active, no damage. Now what to do? Let's test. When you start, you should remember one side of the armature should be towards one side of the magnet and the other side here also. Now tangentially you have to brush. That means we are brushing but manually, not by any spring mechanism. And the moment I touch on both the rings, you find it rotates. Now see, the arrangement is so smooth, there is no complication for the movement of the armature, and armature must rotate. Now I have to show you that your direction of the rotation can be controlled by the placement of the positive and negative wires. See first which direction it takes start. Red down, black up. It is towards me. That means if you face this way, it is anti-clockwise. Now please check, I reverse, red up, black down, and obviously we are expecting it should go to the camera side. And listen to the sound of the armature when it rotates. You might have noted when your electric bikes are running, there is a smooth sound coming from the motor. But here the sound is not that smooth because of the roughness of the holes. These are simple holes and there is a little bit of vibration. If you place bearings there, your rotation will be completely soundless. Now as I discussed, this is the fundamental armature. It is having a single coil and two sides, side 1, side 2, and your commutator is having dual segment section. So this is fundamental. Now I keep it here. The next modification I did, this is a commercial design, all small DC motors we use in our toys, they're having 3 coil sections. But surprisingly, they do have 3 segmented commutators also. Now I can show it to camera. Segment 1, segment 2, and segment 3. So the coil arrangement is such that 2 coils must be joined on a single segment, and you are having 3 pairs of junctions. So 3 pairs means 3 segments to be connected or soldered. Now this is little bit heavier I made, so it will be little difficult to run it, but I will try it. But before that I must go to the commercial design, the armatures we use in all universal motors, like your grinder motors, all those kind of like that. They have got multiple segments of commutator. Commutator is single name, but the segments are either 22, 24, 18, 12, something like that. But remember, as I do not know exactly. I will request my colleague to answer for that. That they are always even or odd.
Yeah, they are even.
They are even.
They are always
So,
even.
so this is a beautiful answer by my colleague because he is an electrical engineer. So he says your segments must be even numbers. As you say, it is 3 here. Now,
We have tested with 2 and 3,
yes,
even and odd both.
Mhm.
But in commercial regions, they are in even number.
Even.
Hmm.
So let's load it. I saw it. This is a beautiful, I made a lot of effort for our junior students to learn that. Lot of effort, I say it's not easy because there are multiple coils to be posted, and where to start, where to end. There is a study, total engineering study. And now let's test again. Same way you have to test your junction is powering or not. To me, I have to show it to camera. The power is active. This is a 12-volt lamp. That means our motor is getting 12 volt and some milliamperes. Hardly 1 ampere maximum. Now I put red up, black down, and you can see the rotation starts. But there is a problem somehow. Maybe in my problem, maybe my placement. See, this is rotating towards me. Again, I reverse as I committed, black up, red down, and you are observing that the rotation will be clockwise. Somehow, for students' purpose, the trial model, everything, there will be little bit of complication. Now, I take it there, it goes there again. It has to obey the laws of science because laws are natural laws. These are all natural laws, even though some scientists have experimented on this, like Michael Faraday, Tesla. I do not know exactly who is the pioneer of the commercial DC motors. Is not easy to answer because this is a long history of mankind. Man is busy in developing series, step 1 to step 100, step 1000. So the present generation, segmented, multiple segmented commutator, and then multiple coils. And now what I do, I have to show you if I reverse it, this side, that side, whether that is working or not. Let me check again. First you check whether it is free, then you check whether your power is active or not, then you touch and see your knowledge is consolidated. Beautiful. Hats off to the scientists and technologists, those who have initially designed these things. We just learnt from our seniors, from our gurus, from our experts, and we pass down this knowledge to our juniors who are present here. I do not know how many are present. I came to know only 4. Now we will upload it in the future sessions. I hope you'll be happy to note that my first DC motor got 1200 views till now. I think this will be better than that. So This is the idea. Now let me check what are the questions till now. Come to the chat box, participants, please. We'll discuss the questions one by one. Let me see. My colleague will see that. Is there any question, sir? Please confirm that your current is ready. Now let me go for this commercial design DC motor. I load it. See, you will be astonished to see that there are loose items, But even though they are loose, I tell you, this side, what is the problem? I show you by camera. The armature is not totally in the zone of the, so we have to shift it. I planned for a 30-minute program, so let's continue, because the session may be interesting because this is an experimental session. See, I check, this is very free, but the way I have to brush is little bit technical. I rotate it towards the camera and keep it like this and try my best to show all of you. If this rotates, I'll be very happy. It will rotate. Yes, it has rotated, but the brushing angle is different. You might note previously I was posting my wires up and down, but this time I'm not posting up and down. Even though I post up and down, this will not start. Something tangentially, some angle, I will discuss, my colleague to discuss about that. Why is that a blunt angle, a tangential angle?
Because in this setup, the magnetic field is two poles, 180-degree apart, and in our armature there are three coils. So the power will given at a time to only one coil, and the position of the segments of commutator, there are three segments, so 120-degree apart each other. So you have to brush in such a way that two adjacent sections of the commutator will get power. That's why our brushing angle is not purely anti-parallel. So some angle has to be maintained so that the 120-degree shift commutators will get power at the same time.
So what I came to know from him, two coils must be powered at the same time. That means your three segments of the commutator are designed such, anytime one will be left free and other two will be connected. Even though it is left free, current will be flowing through all coils. So this is the commercial design, all coils will be taking part in the rotation. But in our fundamental design, only a single coil is taking part in the design, in the effective activation. But here all three coils are getting power. That means current is flowing in all three conductors, and they are all effectively interacted by the magnetic field. In such a manner, the couples produced, they favor each other to rotate, otherwise, they won't rotate. Couples must be in a single direction. Now we have to change the rotation. See the position of the left, that means the black wire and the red wire. I will reverse it. This was rotating in a clockwise fashion. Now it is my duty to show you whether that can be arranged for a anti-clockwise section or not. This is called, the self-starting mechanism. So the design is like this. You should not touch it by your finger. But for my situation, I admit there is some lacuna which we will overcome gradually, because the research and development in our level, we are not experts. We are just passing the knowledge to our juniors. So we have to work hard with our juniors while doing a proto model. The idea of demonstration here is not to show my friends, but I have to advise my juniors who are present. They have to start doing, and they have to feel by themselves what is the reality of the knowledge. Now this motor is rotating in an anti-clockwise manner. You see, because of the heaviness of the coil, the whole system is having a lot of vibration, but sound is less. This vibration can be reduced by reducing the mass of the armature. But in my design, the fault is that I have overloaded the armature with a heavy length of coil. But ultimately, I'm very happy that all our plans worked successfully, and our participants who attended the live streaming session have enjoyed a lot. And now I request participants at least to put some questions on the chat box, that we have to find out how serious are our participants are. Now, before concluding, I must load the fundamental armature. And there was a lot of question regarding why the armature rotates. The answer, again, I will show it, because this is very interesting. What I have to do, I have to take my power little close, and then I have to show it. I put this wire here and take these two pipes out. See, this is the design. You can modify your idea any moment. Now this is inside the magnetic poles, and what I have to do, I have to connect here, and I have to show you what happens to that red wire, why the coil rotates. Why this is not happening, I show you. The day when I showed it, I connected a 4 ampere lamp here. Today this is some milliampere lamp, so the conductor is not experiencing a high force. Still, you can see it is kept over the pole, and the moment I touch my wires, because of the force upon the conductor, it has to come out. It came out. I keep it this side. Let's see what happens. See, this side and that side the same result. This red wire is experiencing a force out, obeying the Fleming's left hand rule. This is the field direction, this is the direction of the current, and force will be up. I repeat, this side is very good. Let me test again. That's nice. And now I keep this wire here and then connect. We will check what happens the next. Do you want to see the highest possible result? This will be done now, but for a moment only. Please observe. This came down. Repeat. This has to come down. This is called short circuiting current. And now similar way, if I want to show it to you again here, this will be here, and what I have to do, I have to short circuit, and you have to see what happens to that red wire. It's coming out. Even this side, if I keep it here also, you can see this is coming out. Baap re baap. You could see children, participants, seniors, juniors. This is mind blowing. I never see such a nice experiment in my career. This wire will be coming out with lot of force. I said, Baap re, why it is so? See, this wire was inside, this is thrown out like this. And what happens to this wire? This wire is out, already outside, and this will come in if you plan it accordingly. So there are two forces acting on both the sections. What is the science behind? Suppose this is the side of the coil and another side of the coil. So one side is experiencing a force down and another side experiencing a force up. So there is a fixed shaft. Arrangement is so that this has to rotate, otherwise there is no other way for that, because this is not free to come out like that. So I hope we have enjoyed a lot, and I do not know whether charts are ready or not. Any questions, sir? So thank you all participants, and like that only we will continue lot of live sessions in future. Thank you all. Have a nice time.